Welcome to the engineering class for December the 7th. This is the engineering principles class. I record the engineering technology class separately. For a long time, I had you guys doing basically the same things that I had the ninth grade class doing, although you guys were doing more challenging problems. But now we've gone in completely different directions because the stuff that you're doing right now, there's no way that the ninth grade engineering class could handle all the math that's involved. So I'm having them do something that's totally different. Okay. Speaking of people having trouble handling the math, when I looked at the homework that was due today, I looked earlier this morning and most of you had submitted something. A few of you just barely submitted some stuff that I haven't had time to look at yet. But as of the stuff that you had turned in earlier this morning, I saw that some of you're really getting it very well, but there's a fair number of you who are still struggling with this. So what I'm thinking I'm going to do today is I will go over the homework, all of the problems, we'll go over them all together, but you realize that if we go over them together, that means I can't let you go back and redo them for credit. We'll have to figure out some other way to get you guys credit. And then we'll go on to some new material after that. Okay, so let's talk about the homework. So here I'll share my screen with you. All right, you should now be seeing my my Canvas page. And so we'll go into the assignment for last night and we'll just do every problem together. And I think what I'll do is I'll have you guys do them again, even though most of you already done them. I'm going to have you do them and type in the answer into the chat box in a private message. I think that is the way that works really well. Okay, so question number 1. I want to know the magnitude and direction of the southward component of a force. It's got a magnitude of 18,500 pounds and it's pointed at an angle of 25 degrees west of south. So I want you guys to tell me in a private chat message, what is the southward component? All right, I see one answer already. Let's see if the rest of you can find something here. Okay, I'm seeing 4 answers now. And the 4 answers that I'm seeing are all the same, which is definitely reassuring. But I want everybody to answer. And if you don't know, go ahead and type into the chat box saying, I don't know. But I need an answer from everybody. Okay, there's still a few of you haven't answered yet. Don't make me call you out by name here, guys. Okay, still waiting on a few. So Presley, haven't heard from you. Gladys, just heard from Gladys. Okay. Luke, I don't think I've heard from you yet. Moses, haven't heard from you. And Trey, haven't heard from you yet. Okay. All right. One of you just admitted to me that you didn't know. And thank you for the honesty. I appreciate that. Okay, 2 of you just said that now. All right, so those of you that haven't answered, presumably the reason you haven't answered is because you didn't know. And so let's see, who was the first one to answer here? Looks like, oh, there was Trey. Trey did answer. Okay. All right, Trey, you were in fact the first one to answer. So could you walk us through how to do this? Go ahead and unmute yourself there. Trey, yeah, Trey, Earth calling Trey. Come in, Trey. Can you unmute yourself and tell us how to do this? Do you not have a microphone?
Oh, I thought I was unmuted. Sorry. Hi.
All
I
right, I
thought
can
it
hear
was
you now.
good.
Okay,
Okay, you can hear me? You good?
yeah,
So
okay,
what I did to find like the southward one was like I drew like a picture
okay.
first
Always a
to
good idea to draw a picture. Okay, so here's our north, south, east, west picture. All right. And the picture says that it's at an angle of 25 degrees west of south. So is that this angle here? Let's call that choice A. Or is it this angle here? Call it choice B. So Trey, which one of those correctly shows 25 degrees west of south?
I'm pretty sure it's is it B?
Oh, don't say it
That's
with a
what I
question
did.
mark in your voice. Say it with an
Well, I did.
exclamation mark in your voice. Okay, it's definitely B. Okay, so then we have the force here, the magnitude of it is 18,500. And this angle right here, that's the angle that's west of south. And so that is 25, right? And so we want the southward component. Okay, so Trey, I've drawn the picture the way that you told me to. What do I do next?
Um, we want to find the southward like component. So
Okay,
that's that's adjacent to the angle. So we are
okay, so
using
all right, so first off, let's draw the components. All right, so I want two non-funky vectors that together add up to take me to the same place that the funky vector takes me to. And this angle that we've drawn here, I want that to be inside the triangle that we end up with. Okay, so I'm proposing that if I were to go straight south, and then when I get to here, I turn and I go straight west, okay, those two blue angles will add up to be the same as that one red angle, okay? So those are the components of that red angle. Okay, so I'm gonna label this one X, I'm gonna label this one Y. And so Trey, which one of those is the southward component? Is it X or is it Y?
Y.
Okay, you guys agree? Okay, so the blue arrow that I've labeled Y, that one is the southward component. All right, so Trey, now I want to come up with a number for what Y is equal to. How am I going to do that?
So Y is like adjacent to the angle, and we already
Okay,
know the hypotenuse. So that would be the cosine.
okay, so adjacent over hypotenuse. So apparently Trey is thinking in his head, he's thinking about this thing called SOHCAHTOA, and he recognizes that adjacent over hypotenuse, that's cosine. Okay, so then he's going to say that the cosine of the angle, which is 25, is equal to the adjacent, which we don't know, so we call that Y, divided by the hypotenuse, which we do know, which is 18,500. Okay, and now it's just an algebra problem. All right, so Trey, what do I do?
Multiply each side by 18,500.
Okay, so that cancels that. But whatever I do the right side, I have to do the same thing the left side. Okay, and so what number did you get there, Trey?
I got like 16,800 for Y.
Okay, all right, good. Now, is that rounded off or is that not? So
It's it's
18,500 times the cosine of 25. Okay, yeah, so the number in his calculator is actually 16766 point a whole bunch of other stuff. Okay, so that's the number that appears in the calculator. And so what I discovered when I looked at the homework is that some of you, I think you're having a little trouble with sig figs. And so you'll see in the question here, it says, give your answer using 3 sig figs. So I have to take my answer and I have to cut it off here. So I'm either going to round it down to 16,600, or I'm going to round it up to 16,700. So if this digit right here is a 6, then obviously rounding up was the way to go. I'm sorry, rounded up to 16,800, or rounded down to 16,700 is what I meant to say. Okay, so rounding up is clearly the way to go. Okay, so the answer we type in the box is 16,800. Okay, Now, I realize that more than half of you got that right. And so more than half of you are sitting here saying, why are we spending time doing this? But a substantial number of you, I mean, less than half, but still more than a fourth of you guys had trouble with this. So this is something you really need to be good at. If you're a civil engineer, this kind of stuff needs to be something that you can do without having to do any thinking about. It just comes naturally to you. Okay, question number 2 now. Same thing as before. I want you to type in the answer into the chat box, and I want everybody to do it, please. And I'm going to keep track of who does it. And if you don't do it, I'm going to call your name out. I'll try not to make it too threatening here. All right, so I'm seeing one answer. And okay, another one. Good. Okay, so I see it's the same people who are answering really quickly. Oh, there's a new person who didn't answer quickly before. That's reassuring. Okay, good. All right. Okay, most of you have answered, but there's still a couple of you who haven't. Don't make me call your name out. Okay, good. Thank you for that answer. Okay, thank you for admitting that you're not sure how to do it. I won't call your name out. Okay, and if the rest of you will be honest and admitting that you don't know, I won't call your name out either. But if you don't put something in, I'm going to call your name out. Like, for instance, Luke. Okay, I'm not seeing one from you, Luke. Ahmed, I'm not seeing an answer from you. Oh, there, never mind. I just saw one from Ahmed. Okay. All right, Luke, you're the only one who hasn't answered yet. Are you still there, Luke?
Yep, I'm doing it right now.
Okay. All right. Okay, so I see most of the people who answered said 550, but a few of you said 555. Okay, but almost everybody said 550. Okay, so the one of you who said 555, all right, you just need to read the problem a little more carefully. This time the problem said to give your answer using 2 sig figs. Okay, and now sig figs are important. Engineers need to really be concerned about sig figs. Okay, back on question number 1, if you look at the answers, or if you look at the input numbers that I gave you, one of your input numbers was this, and notice it has 3 sig figs. The other input number was this, and it has 3 sig figs too. Now that 0 that you see, that's a 0 after the decimal. So that's not just a placeholder. That's actually a significant figure. So that's the reason why back in problem number 1, I asked for 3 sig figs. That's because the input numbers that I gave you all had 3 sig figs. But in problem number 2 here, you can see it's a little different this time. In problem number 2, I've got a number here that only has 2 significant figures, and this number here only has 2 significant figures. So that's the reason why the answer can only have 2 significant figures. So I'm helping you out by telling you how many sig figs you're allowed to use. Later on, I think I'll stop doing that. Later on, I'll expect you to know how many sig figs you're allowed. Okay. But it looks like everybody pretty well agrees that the answer here is 550, and everybody got it, well, except for a couple who admitted that they didn't understand where to put the numbers. Okay, so let's talk over just really briefly where to put the numbers. Okay, so let me clear this out. So what have we got? We've got a force that's going straight north, and it's 260. Okay. At the same time, we've got another force acting on the object. So if I were to draw the forces the way that they're acting, okay, this is the way that I would draw them. They're both acting on the same point. Okay. And then, so if we look at the hypotenuse is going to be this one right here. But if I draw it like that, people are going to get confused because they're going to think that the net force is either to the northwest or to the southeast. And that is not, in fact, the way that it works. The net force is actually going to be, I mean, if we got one to the north and one to the east, the net force is clearly going to be kind of northeast-ish. There's no way it can be northwest, no way it can be southeast. All right. So even though this picture that you see right here best illustrates what's happening, it shows that both of the forces, oops, I hate it when I do that. Let's try that again. Okay, so both of the forces are acting on this point right here. When we add vectors, the best way to do it is draw one of the vectors first, and then the other vector, even though it's actually acting down here, we don't draw it down here. We draw it starting where the first vector ended. And so this is our 490 vector. All right, so now we can draw the resultant vector. The resultant vector is the one that starts where they started and ends where they ended. You'll notice that the resultant vector is going kind of northeast-ish. Okay, so that's good. All right, so then how do we figure out what the magnitude is? Well, just use Pythagorean theorem, right? And so when I do that, so I'm going to take the square root of 260 squared plus 490 squared. And when I do that in my calculator, 260 squared plus 490 squared gives me that. Take the square root of that. Okay, so the number in my calculator is 554.7. And so now I'm only allowed 2 sig figs. So it means I got to either round it down to 550 or round it up to 560. Okay. And so rounding down is clearly the way that we're going to go. So 550 is going to be our answer. And almost all of you got it. Okay, now question number 3. Same problem, but this time I want to know the angle. Now, notice that the question is asking how many degrees north of east it is. So if you look at the triangle that I drew here, this angle here is the angle that we would get if we work with our numbers. This angle is east of north. And the question wants it to be north of east. So what I can do is I could calculate that angle and then just divide it by 90. Or what I could also do is I could draw my forces vector differently. Instead of doing the north vector first and then the east, what I could do is I could do the east vector first and then the north. And it'll take me to the same place. Okay. Except that this time when I do that, then the angle that's inside the triangle there, that will tell me how many degrees north of east it is. And that's what we were asked to find, was how many degrees north of east. Okay, so again, this one here was 260 and this one here was 490. Okay, so I'd like you guys to do it now. I want you to calculate what is the angle for that red, how many degrees is that red angle? Okay, so I want everybody to do it. All right, I'm starting to see some answers coming in. So far, the answers that I'm seeing are the same answer, which is definitely reassuring. Okay, I'm seeing a different, that last one that just came in was different. Okay, now there's another one that's the same as the others. Oh, that one was completely different. Okay, so I'm seeing 3 different answers now. Okay, I need to see some more of you. Don't make me name names again, guys. If you don't know, type it in. Type in that you don't know, or yeah, that you're not sure. That works. And that way I won't call your name out. Okay, so I see a few of you. Thank you for admitting that you're still having a difficult time. I appreciate your honesty. That's the reason we're doing this. Okay, so let's see. Who should I call on here? Some of you still haven't turned it in yet. Eliza, you were one of the first ones to put in your answer. So Eliza, can you tell us how did you do this?
Yeah. So from that drawing that you have there,
Mhm.
then I just used tangent since we have
And
the
why did
opposite.
you use tangent?
Just since I knew for sure that the opposite and adjacent sides were right.
Okay, so this 260 here, that one is the opposite side. This 490 here, that one is the adjacent side. Okay. And so she's thinking opposite, adjacent. Looks like TOA where the T stands for tangent. Okay, so she decided she wants to use tangent. Okay, so tangent of theta equals, go ahead and take it from here, Eliza.
And then so you're going to do 260 divided by 490.
Okay. All right. Now we're trying to solve for theta, so we want to get rid of this tangent. So a lot of people think, well, let's divide by tangent, but hopefully by now you guys realize that's not the way it works, because it's not, what we have here is not tangent times theta, is tangent of theta. So dividing by tangent isn't going to work. So Eliza, how are we going to get rid of that tangent?
We're going to divide it by inverse tangent on both sides.
Well, don't use the word divide by. Just, I would prefer that you say, take the inverse tangent of
Okay.
both sides. Okay, so we're going to take the inverse tangent of the left side. So inverse tangent cancels tangent, leaves us with just theta. But whatever do the left side, we have to do the same thing the right side too. That's the laws of math. So inverse tangent of 260 divided by 490. Okay, and when you put that in your calculator, what did you get?
27.95.
Okay, so 27.95. Okay, which is too many sig figs. So if we round it off to 2 sig figs, clearly we're going to round it up to 28.
Yep.
Okay, so those of you who told me that you were a little unsure about this, does that help? Is it starting to make more sense now? Okay, hopefully. All right, good. Okay, that's reassuring. Okay, let's do a couple more here. Let's go to problem number 4. Okay, oops. Problem number. Oh, okay. Yeah, question number 4 is just asking how many degrees east of north. Okay, so if we've got our drawing that looks like this, okay, so if we know this angle here was 28 degrees, then what would the angle be if we had done it the other way? If we had gone up and then over, so we get this angle. So what would that one be? Well, the two of them have to add up to be 90, right? So whatever 90 minus 28 is, okay, that's going to be the answer. So I'm thinking, what, 62? Is that the right one? Okay, all right, good. All right, so hopefully you guys are seeing these aren't as difficult as you may have thought that they were. All right, so question number 5. Let's do this one. And again, I want to do it the same way. I want you to solve it on your own and then type in the answer in the chat box using a private message. And I'm going to keep track of them here. Okay, I've got one answer in now. 2. Okay, and I see a few people who are saying you don't know how to do it, so thank you for your honesty. Oh, quite a few people are saying you had trouble with this one. Wow. Okay. All right. Well, thank you for your honesty. Appreciate that. Okay, Zaid, you were the first one to give us an answer on this. So can you tell us how to do it? Tell me what you want me to draw, and I'll draw whatever you tell me.
Okay. Degrees magnitude. Nothing unknown. Okay, so we draw 730 pounds. Okay. I didn't do it exactly 15 degrees. I just did it like as if it were going.
Yeah. Tell you what, I'll draw the picture. So here's our north, south, east, west axis. Okay, so the first force is 15 degrees west of north. Okay, so that means our first force is going off like this, where this angle here is 15. Okay, and the magnitude of that force is 730. Okay, that's a lousy 0. Let me see if I can make that 0 better. Okay, now at the same time, we have another force that's going to the east. Okay, and so here's this. And so this force has a magnitude of 510. Okay, so we need to add these two forces, but one of them is funky. And so people get nervous when they see funky forces. So Zaid, what do you do when you see a funky force?
So we will break it down into its components.
Excellent. We'll
And
break it into its components. Okay, so that one funky force that you see is the same thing as this one non-funky component added to this other non-funky component. So I'm going to call this one Y and I'm going to call this one X, just because I like horizontal as X and vertical as Y. Okay, so if we could figure out what number X and Y were equal to, hopefully everybody agrees that those two red components do the same thing as that funky blue 730 force do. All right, so Zaid, how would I figure out a number for what Y is equal to?
so we know what the hypotenuse is because that's 730, and we also have an angle. Um, so we can, if we have the hypotenuse and angle, and we want to find x, we know that x is the opposite. So we find which sine, cosine, or tangent, which one is opposite over hypotenuse.
Okay, so opposite over hypotenuse, and which one is that?
It would be sine.
Okay, so the sine of the angle, which we know is 15, is equal to the opposite, which we don't know, and so we decide we're going to call that one x, divided by the hypotenuse, which we do know, which is 730. Okay, so Zaid, what do I do?
You multiply both sides by 730.
Okay, so let's multiply both sides by 730. So that cancels that. So I get 730 over here. Okay, so 730 times the sine of 15. Okay, so when I do that, I get that x equals 188.94, which is more sig figs than we're allowed, but it's good to carry a couple extra sig figs. Okay, you don't want to go rounding off to 2 sig figs too early. You're going to get yourself in trouble. All right, so we now know that x is equal to 188.94. Okay. All right. So now I want to figure out what y is. And so Gladys, would you tell me what do I need to do in order to figure out what y is equal to?
So it's sort of like how we did x. So
Mhm.
because we know the hypotenuse and the angle,
Uh-huh.
y is our adjacent, so we just would find the equation that would be like adjacent over hypotenuse,
Yeah. And which one of our three friends is that? Sine, cosine, or tangent?
cosine.
Very good. All right, so we're going to do the same thing, only this time we're going to use the cosine. So the cosine of 15 is equal to the adjacent, which is y, divided by the hypotenuse, which is 730. Okay, so we're going to multiply both sides by 730, if we can write it properly. Okay, so y then is equal to 730 times the cosine. So 730 times the cosine of 15. So I get y is 705.13. Okay. So I'm going to go ahead and put that over here. So 705.13. Okay, so now watch what I'm going to do. Now that we have those red components, they accomplish the same goal that that blue funky vector did. So I'm going to just get rid of the blue funky vector. We don't need him anymore. Those two red component vectors, they accomplish the same thing. Okay, so now some of you are going to say, but we used to only have to add we used to only have two forces that we needed to add in order to get the answer. And now we got 3 forces. Yeah, but they're non-funky, and that makes all the difference. Okay, so what I'm going to do now is I'm going to use this symbol that hopefully you guys have seen before. This Greek letter sigma that means add them all up. So if I add up all of the x vectors, okay, so I've got 510 to the right, and I've got 188.94 to the left. So if I add positive 510 minus, because the left is minus there. So 510 minus, or if you prefer, plus a negative, 188.94. Okay, so what that gives me, if I add up all of the x vectors, I get, let's see, 510 minus 188.94. Okay, so I get 321.06. So that is what I get when I add up all of the x vectors. Okay, so they've been taken care of now. I don't need to worry about them. Now I need to add up all of the y vectors, which is really easy because I only have one y vector. So if I add up all the y vectors, what I get is 705.13. Okay, so now I know these are the components of what my final answer is. So what I'm going to do is over on the left side here, I'm going to draw my north, south, east, west drawings. Okay, and so if I've got my x is positive 321, and tell you what, I don't need those guys anymore. Let's just round it the nearest one. Okay, so my x component is 321, and that's in the positive direction. My y component is 705, and that's also in the positive direction. 705. Okay, so those are the components of my final answer. So my final answer is the vector that starts where they started, ends where they ended, and doesn't care what happened in between. Okay, so all I have to do is just Pythagorize these two guys, and that'll be my answer. So 321 squared plus 705 squared. Take the square root of that. And so I get 775. Actually, 774.6 is the better way to write it. Because remember, if we round off too soon, you get yourself in trouble. Okay, so let me clear some space here. Okay, so the magnitude of my final answer is that guy right there. And now how many sig figs am I allowed in my final answer? Well, it's saying here that it wants 2 sig figs. And the reason it wants 2 sig figs is because that input number only has 2 sig figs in it. And that one, and also this one over here only had 2 sig figs. Okay, so that means I need to round my answer down to 770. That is going to be the magnitude of my final answer. Right? Now, question number 6 is I want to know the direction. And so the question here is saying I want north of east. And so if I look at my drawing, well, that's perfect. That's exactly what I've got. That red angle that I just drew right here, that one is north of east. Okay, because that 321, that one is perfectly east. So if I go north of it, that'll take me to the red vector, which is what I want. Okay, so I want everybody here to calculate what is that red angle. You guys should all be able to do that. Okay, I'm seeing one answer. Come on, I want to see some more. Okay, now I just saw another answer. Now I've got 2 answers that I'm seeing right now that are slightly different. So I'm thinking it's probably rounding is the problem. One of you rounded the wrong way. I'm not going to tell you which one. Let's get a couple more answers in here. Okay, that last answer that just popped up is completely different from the others. Now, it could be that you're right and they're wrong, but odds are not good. Okay, and I just got another answer. Okay, now I'm starting to see, but interesting, the answers seem to be split. So most of you are saying 66, but there's quite a few of you that are saying 65. All right, so hopefully you guys recognize that one way to do this is let's work with these guys. And then I'll take the tangent of theta equals 705 divided by 321. Now, others of you might have said, well, hey, I'd rather not use the tangent. I'd rather work with this guy and this guy, which that certainly is allowed. So if you want to do it that way, then what you would do is you would say that the sine of theta equals 705 divided by 774.6. Notice I'm not using the rounded off numbers there. Okay, and I'm thinking that we should get the same answer either way. Okay, so if tangent theta equals this, then that means that theta is equal to the inverse tangent of that. So let me take the inverse tangent of 705 divided by 321. Okay, and I'm getting 65.51, which rounds off to 66. Now let's do it the other way. Let's use the sine. So I don't want sine theta, I want theta. So I take the inverse sine of both sides. Okay, so if I do inverse sine of 705 divided by 774.6, I get 65.52, which, hey, what do you know? Surprise, surprise, works out to be the same answer, either way that I do it. Okay. All right, so you see math works. And you can see there's a couple different ways we could do this, but we get the same answer either way. Okay, last one here. Question number 7. This is the one that most of you had trouble with in the homework. And so I'm going to give you a couple minutes to think about it now. I'll help you by drawing the picture for you. All right, so what we've got here is we have a force that's pointing to the west. So so here's my north, south, east, west again. And we've got a force that's pointing straight west. Okay, and it's 39 pounds. And we've got another force that's pointed straight north, and that one is 44 pounds. And we want a force that is going to balance these two. Okay, so hopefully you realize that the force is going to have to be going kind of southeast-ish. That's the only way that it can work. And that force is a funky force. So if I were to break it into its components, you could have a component that goes like that, and then the other component that goes like that. So those two, in fact, let me do those in a different color, just so that it's easier to talk about them. So I'm going to do those in green. Okay. So the green component that goes straight east, and then the green component that goes straight south, okay, those two components work out to be the same as the red one, okay? So what number would the x have to be, okay? If I want to take sigma x, and if it's going to be in equilibrium, that means if I add up all the forces in the x direction, it has to equal 0. So I've got a force going to the left that's 39. So what does this guy have to be then in order to balance it out? Somebody type in the chat box. Tell me it has to be 39. Okay, now some of you said negative 39. And so the negative just tells you the direction. Okay, so 39 to the left could be balanced by a force to the right that's 39. Okay, now, but what about y? What would y have to be in order to balance out that northbound force? Okay, so y would have to be 44. And again, some of you said negative 44, but remember the negative just means the direction, and my picture tells me the direction. Okay, so I know the components of my answer. So the red vector that you see there, that is the answer, but I know what the components are. The x component is 39, the y component is 44. So how could I figure out what the magnitude is? Well, just Pythagorize those guys. Take the square root of 39 squared plus 44 squared, and that will tell me what is the magnitude of the red vector. Okay, so 39 squared plus 44 squared gives me that. Take the square root of that, and so I get 58.79. So if I round it off for 2 sig figs, that gives me 59. So 59 is the magnitude, okay, of my red vector. So that is the magnitude. And then what is the direction? Well, if I do the inverse tangent of 44 divided by 39, that will tell me what is the angle. So I'm going to do the inverse tangent of 44 divided by 39, and I get 48. Okay. Now, I want you guys to type into the chat box, that angle that I just calculated, is that how many degrees south of east, or is it how many degrees east of south? Everybody type into the chat box and tell me what you think. Interesting. Most of you are saying south of east, but one of you said east of south, which, to be honest, is about what I expected. Okay, so how do you know whether it's south of east or east of south? So Presley, you said that it was south of east. Well, why do you say that? Can you unmute yourself? And how did you come to the conclusion that it was south of east rather than east of south?
I hate
Let's call him
this
Presley.
mic. Well, I'll be completely honest. I just kind of went with the flow.
They just kind of went with the flow. Okay, thank you for
Yeah.
being honest.
I'm not fully
Marshall.
confident on this.
Okay, I appreciate the honesty. That's good. Marshall, why did you say it was south of east? What was your thought process?
Well, because the angle is kind of pointing south, so it's going south, but the angle is like, I don't know how to explain it.
Okay, all right, appreciate the honesty. Here's the way that I recommend you guys think of it. Okay, so look at the arrows that you see that are on either side of this angle. One of those arrows is going in a nice pure direction, and the other arrow is the arrow that we're interested in. It's the answer vector. Okay, so relative to that pure direction, which by the way is east, what direction, if we were to start at the pure direction, which is east, what direction from there would we have to go in order to get to the arrow that's our actual answer? Well, we would have to go south of there, right? So if we start off at the east, we would go to the south in order to get to that guy. So this angle that we just calculated, that is the angle that is south of east. Now, if I wanted to, I could ask you for this angle right here. Okay, so that blue angle. Okay, so you see, if we start off at this angle right here, that's the nice pure non-funky one. So you always want to start at a non-funky one, and then you go whatever direction you need to go in order to get to the answer that's your final answer. So if you start at the south and then you go to the east of that, then that will take you to the answer that's the final vector. So this blue angle, it tells you how many degrees east of south it is, whereas the black angle tells you how many degrees south of east it is. Okay, that makes sense to everybody? Give me yeses or nos on if you feel a little more comfortable with that now. Okay. All right. Okay, good. So, all right, that's it for last time's homework then. Now, I did have some new material that I was hoping to get into. do we have enough time to do it, or would it be better? Would you guys prefer to have one more day doing problems very much like this? Or you feel ready to move on to the new material? So I want you to type in the chat box, either say move on or a day of review, please. Okay. All right, looks like now a few of you are saying you could move on, but most of you are saying that you want to do one more review assignment. Okay, all right, I'm willing to do that. Okay, so let's do another day of review here. So if we go into Canvas, if you go back up to the modules. Okay, so when you come down to here, you're going to see analyzing forces in a truss structure, which is due next time we meet. Okay, so here, let me change that. I'm gonna change it so that instead of being due on Wednesday, I'll make it due next time we meet, which will be Tuesday of next week. Oh, good grief. Tuesday of next week. Yeah. Okay, well, that's what we'll do. Okay, so that's going to be due on Tuesday of next week. And by the way, that 10:38, that's not right. 12:44 is what it should be. Okay, so the assignment that you saw in Canvas there, I've now changed that. So don't worry about this one here. We'll talk about that when we meet on Wednesday. So what I'm going to do instead is I'm going to create a new assignment. And you guys can see here, if just in case you're curious knowing how it works. So I'm going to come in here and I'm going to put in a new assignment. And the assignment is going to be more with forces. Actually, I think the last one was titled more with forces. So I'm going to call this one still more with forces. Okay. All right. And so I'm going to make this one be due next time we meet. Okay. And I'll make it be worth 10 points. Okay. And so this one will be due on Wednesday at 12:44. Okay. Now I'm not going to publish this one yet because I haven't written the questions. So what I need to do now, and I'm not going to have you guys watch while I do this, but I'm going to go into the edit thing here. And I'm going to write some more questions very similar to what we had last night, but not exactly the same. Now it's going to take me about 10 or 15 minutes to do that. So here's what I propose we do. Okay. I'm going to go ahead and end the Zoom session right now. We still have about 25 minutes left in class. Okay. It's going to take me 10 or 15 minutes to make up some more questions. So you guys just you just relax or work on another class's homework assignment or whatnot for the next little while, and then come back in about 15 or 20 minutes. And then I will have some new questions posed for you that'll be very similar to the ones we did last night. Not exactly the same, but similar. And then that'll be your homework for Wednesday. So are you okay with that? All right. Okay, so I'm going to go ahead and end the meeting then. So give me a little while to write the assignment and then come on back and then do the assignment for Wednesday. I'll see you guys later.